Start recording. All right. So welcome everyone to our first webinar of the First Nations Launch 2024 cycle.
It's two, isn't it?
Oh, well, technically the second one. The first one was for our mentors. But so this one will be focusing on proposal, budget, design review reports. So it's to try to give you guys that overarching coverage of what you'll need to be working on, some of your deliverables for us. So quick overview of what we'll be going through today, the milestones, the schedule for your design reports, what we expect out of the different checkpoint reports that you'll have to be giving. We'll be touching about the fly sheets, a little on the project management, and as well as the budget. And we always like to start off with just reinforcing the team members that you have involved. From the Wisconsin Space Grant, we have Kevin Crosby, our director, Christine Bowles, the assistant director, and FNL project director. She's also on the line with us today. I am Rob Cannon. I am the project manager. We have Connie Engberg also on the line today. She is our amazing project support assistant. Megan Goller she helps with all of our reimbursements. And then, of course, as all of you guys will get to know intimately, Frank and Mark, they are project assistants for First Nations Launch, and Mark will also be giving our presentation today. And then Tripoli Rocket Association, additional support we get is from Bob Justice and Kevin Harnick from other local Tripoli chapter or precincts. With that, I will hand it over to Mark.
Awesome. Thanks, Rob. Thanks for that. So as Rob mentioned, introduce myself. So I'm Mark Abotossaway. I am Anishinaabe First Nation, and I'm a structures engineer here at Blue Origin. Been with FNL supporting for about 6 or 7 years now, and then alumni of the program. So I competed. I was in your shoes a number of years ago. So been there. So today's presentation, like we said, we'll cover a lot about the reports, what's expected, and give you some tips and answer some questions here about what's expected. So as in any good engineering program, you got your design milestones. So your initial kind of milestone this year, the first thing you had to do was submit a NOI, notice of intent. So all you teams have done that because you're all here. In industry, there's an equivalent process called request for proposals, RFPs, that industry will put out. So it's along the same lines. And then next you move into your phase gated process. For FNL, we only have 5 phases. There's proposal, preliminary design, critical design, flight readiness, and post-launch. But if you do look at a highly detailed design in any aerospace company, there'll be other gated designs, and usually you must pass the phase. You'll present your phase. You present your proposal, for example, to someone in the company, and then for FNL, that's presenting it to me and Frank and the admin team. And then you kind of got to get a green light to go ahead on to the next phase, and then each phase kind of builds on the previous phases. Sometimes you don't get a green light to go on to the next phase in industry. Sometimes there's some issues you need to go back and rework and look at before you get the next gate. So that's what's known as the phase gated process. Next. So each milestone, so we mentioned the 5 milestones. Each milestone involves basically a design freeze where you will do a written design report. You'll also fill out a fly sheet, and then you'll do a virtual review. And it's starred because not every design phase has a virtual review. And this is same that's held in industry, each of the design phases. The virtual reviews, however, in industry are a lot longer, bigger. They're usually like week-long, 40-hour type reviews. So you guys only get a little 10, 15-minute review. So you're condensing a lot into that 15 minutes. And then drilling down a little further, so you talk about the design reports. Well, what's in a design report? Design reports will include a team overview, usually facilities and equipment. You'll talk about your vehicle design. You'll talk about your challenge design, which is unique for that year. You'll also talk about safety. And then finally, you'll discuss some project management. And then we'll discuss these a little further as we go. Report schedule. So there's a schedule, there's a calendar. Hopefully you guys have seen it. I think it's all over. It's on the website. There's a calendar outlining not just the reports, but kind of all the different dates that you need to be aware of, webinars as well. This is kind of just a summary of the reports. So starting in, Rob put a link in the chat there. So, and a calendar is also in the handbook. But just looking specifically at the reports, your first report is due December 11th, and that's your proposal. And then following that, January 22nd is your preliminary design report. Your critical design is due February 26th. So basically, I think every 5 or 6 weeks, another report is due, another milestone you pass through the gate. And then in conjunction, the 3 milestones there in the middle, the PDR, CDR, and FR, also have a virtual component tied with them as well. So we'll talk about the virtuals and the written report here as we go. Next. So proposal. So what is a proposal? What's expected in a proposal? So proposal phase includes, it is the forming stage of team development. So you're still trying to acquire resources. You're still trying to recruit team members. Many of you have advisors. Most of you have mentors, which is a requirement. Some of you don't. So that's kind of the things you're trying to work out here in proposal phase. You're trying to figure out, well, maybe what labs do I have access to at my campus? What do I need access to at the campus, right? Do I need the student lab? Do I need the machine shop? Do I need the 3D printers? So you're kind of doing the forming stage and figuring out all these things in proposal. So like I said, you're outlining and acquiring the resources needed, and you'll submit that in your report. Understanding rocketry and payload safety. So that's another one too you're doing here in proposal, because especially many of you are new to rocketry. And then the payloads this year are pretty unique. So there's some other specific safety requirements that go along with the payloads. To the veteran teams or veteran members on the call, this is kind of just, a rehashing here. So remember to understand your rocketry and payload safety. And then in proposal, you're also going to have an initial technical design. These are concepts usually. You're going to deal with the rocketry tech design and the challenge tech design. They're 2 separate components. So I want to be clear on that. So just like here at Blue Origin, we make the rocket, but we put something inside the rocket. So someone else may come along and a university might say, hey, we got a payload we want to put in your rocket. So they're kind of 2 different things, right? Rocket should be able to fly with or without a payload. And the payload could be anything, basically. And this year we define the challenge as your payload. So you'll have to look in the competition handbook to understand what the challenge is. But your rocket should be able to carry that payload, but your rocket should also be able to function without the payload. You should be able to take the payload out and still be able to fly your rocket, satisfactory, have a good flight. So at proposal phase, you're doing some trade studies, you're running some simulations, and then you're also drafting your project management. So we'll cover that a bit more here in a minute. You're looking at test plans and requirements, and then you're looking at budget and schedule. So keep in mind, there's also no procurement at the proposal phase. Next. So then just in general, the proposal should show trade studies of various design ideas. So we don't want to see, when we're reviewing your proposals in December, I really don't want to see like one design, like one rocket or one motor or one, performance spec, because you shouldn't have that much design definition at proposal. For you to have that much definition, it would have meant you looked at all the options. And it's like, just by time constraints, there's no way you could have looked at all the options. So in your proposal, we want to see trade studies. We want to see a comparison between, a phenolic airframe and a hand-built carbon fiber airframe or a fiberglass airframe. And you're kind of just weighing these decisions still at the proposal. You're saying, hey, we realize we might want to do this or we might want to do that. You're looking at materials, you're looking at sizes, you're looking at costs. and you're trying to balance the best between performance, cost, and material. And then also in proposal, make sure you're meeting your vehicle requirements, and then you're also examining various payload and challenge options. So depending if you're in Moon or you're in Mars, your challenge will be either the drone or the lander type. So make sure you understand the challenge requirements when you define those, when you make those trade study proposals in your proposal. So you could say, hey, here's our primary option. We're thinking about going with aluminum airframe type device, and we're going to use these components, or we're also looking at using a 3D printed airframe, and these are the components we're going to have on that one. So proposing them, kind of flushing them out. It doesn't need to be at proposal. Your design doesn't need to be 100% defined, so we don't need to see every single component, but just kind of a high level, concepts. It's kind of like, well, this is what we're thinking we're going to do, and we're going to look at the cost, or we're going to do some testing or something like that, mock-ups as we go. Make sure to include RockSim simulations in your proposals. So if you haven't done so already, you should be acquiring RockSim. There's trials and there's support for that in the competition handbook. We also have a RockSim training video on our website. If Rob or County could link the training videos in the chat, that'd be great. And then you're drafting your initial project management documents. So like we mentioned, there's in every report, every milestone, there's going to be a test plan, a requirements verification. You're going to submit your budget, and you're going to submit your schedule. Next. So this is just an outline here, and we'll do a comparison between all the reports, what's required. So you can see your team summary, your facilities. Not so much in vehicle criteria. There's kind of a design overview at proposal, and then your 4 project plan documents there. And we'll cover those in detail later in the presentation. Next. So preliminary design. So this is in the end of January timeframe. And the PDR phase, it's the storming phase of team development. So you're kind of bringing all these resources together. You're bringing all these options together, and you're trying to get the program and the design going. So you're going to look at the technical design of the rocket vehicle, and maybe at this point you've kind of weighed some of the options from the proposal. You might have narrowed down a lot of the component selections by PDR. Not necessary to nail down all of them, but you should have nailed down most of your component selections by PDR. Maybe even constrain some weights or costs or things like that. You're going to refine any component selections you made in proposal. So maybe in proposal you suggested some electronics, and maybe things have changed, or budgets, priorities have changed. You decided to go with something else by preliminary design. And then you'll also update your simulations. So as your design kind of matures, remember to keep updating your simulations and getting that data to us in the report. And then challenge details. So for your challenge, you're going to refine your component selection. So again, deciding the material of your airframe, how you're going to make your airframe, and then what components you're going to buy and put on the airframe, and how they're all going to integrate and function together. At PDR, you'll also have a safety section. So this is just updating the rocketry and the challenge requirements. Make sure you understand those. And then for the project management phase, again, updating your test plan and your requirements, and updating your budget and schedule. Next. So the big picture, preliminary design, right? It's beginning to narrow down your design options. And your focus should be on the payload and the challenge. So, maybe 50% of your resources or your time should be spent on the payload and the challenge. So what we find too in past years, some teams will focus on maybe too much, they'll spend too much time on the rocket or the simulations and not enough time on the challenge. And then they show up to launch weekend, and the rocket's fully mature. It's a nice design, but the challenge doesn't work properly. It's not finished in time for launch weekend. And then vice versa. We've had teams where, they spend a lot of time on the challenge, and then they completely forget to address the rocket and the simulations. So it's kind of that, fine balance. So I would say a preliminary design, focus a lot more on your payload and challenge. It's easy to adjust your rocket selection to match your payload. So if your payload suddenly changes and it grows an inch in diameter or grows, 6 inches in length, it's easy to just order a longer tube or a bigger tube, or manufacture a different size rocket to accommodate your payloads. Of course, like I mentioned, you still may have some uncertainty about other components and ideas. But in your report, please present all of the options. So if you've narrowed something down, say, okay, this is our final selection. We've examined some options. This is what we're going to go with. However, maybe at parachutes, you're like, well, because we don't know our final weight yet, we haven't decided which parachute we're going to use. So we're going to present these 2 or 3 options. At preliminary design, mockups and procurement should begin. So this helps you develop your payload in your challenge. And they may help you eliminate a design choice. Avionics could also be procured by preliminary design, such as your altimeters and your GPS. But however, wait to procure your rocket components and especially your recovery components. So everything like your parachutes, your shock cords, all the rocketry, laundry as they call it. That's kind of something that depends on the final overall weight of your rocket. Because there's a certain descent rate requirement. So you kind of need all the other components first before you determine your parachute sizes or the parachutes you want to use. You're going to kind of want to wait till either CDR or FR to do those recovery components. And then component testing should also be continuing here in preliminary design, starting after proposal. Next. So again, just a comparison back to the proposal. So you see your team summary will copy over. You'll do minor updates. You're not really discussing facilities and equipment anymore. Preliminary design, vehicle criteria and challenge criteria sections are pretty big in PDR. So you're starting to put a lot more detail into the vehicle, a lot more detail into the challenge. And then safety section is always the same in every report. You'll have the safety section, and then your project plan, your four documents there, and we'll touch on those later. Next. So critical design. This phase is the forming phase, and your technical design, you should be finalized in your design. You should have all of your final rocket component selections chosen by critical design. I believe the date was February 28th. So I think it's about 3 or 4 months from now is your critical design. And we want as many components. It should be all, but if you can't get to all of them, it should be as many components selected as possible. So you're going to update your simulations again, and account for all of those components. And then your motor selection is due at critical design. So in order for us to procure your motors in a timely manner for launch weekend, we need your motor selection at critical design. And that's why you need to have all of your components selected, so you know your final, vehicle and payload weight, so you can make your final motor selection. If your motor or your component weight changes or your rocket weight changes after CDR, then your motor is no longer going to get you to what you predicted in the simulation. So challenge details, right? So we also want a final payload component selections. It doesn't need to be built. These are just the component selections on paper. So maybe you have a spreadsheet kind of managing all the things you want to buy or you want to have on the payload in the rocket. And then your safety section as well as in critical design, and then project management. Again, you're updating your 4 documents. Next. So like I said, in a big picture, critical design shows that all the design choices are complete. So again, like I said, it doesn't need to be fabricated 100%. Just all the design choices should be complete. There shouldn't be any variation. You shouldn't have forgot any components. We don't want to see at critical design that, oh, you forgot to pick a motor retainer, or you forgot to, choose the center rings, or you only have, you don't know which switch you're using. So you need to know all these things by critical design. So you want as little mass changes as possible after this date. All your component procurement should be wrapping up. So anything you propose at proposal or preliminary design, this should kind of be critical design is, green light. That's when we're going to finish wrapping up all our procurements or making the final procurement orders to get those in time for flight readiness for the next milestone. All your components should be accounted for in your budget. So you submit those every report. So we want to see all the components in the budget. For Mars teams, you submit a mass balance. So we want to see all the components in the mass balance, the weight of every component. And then your rock sim simulation should also account for every component. So when we review your rock sims, I want to see everything in the rock sim. I want to see every eye bolt, every washer, every shock cord, everything in that rock sim. The weight matters. You do not realize how much all that weight adds up. And then teams usually underestimate their weights. And then the rock sim is usually lighter than it should be. So keep that in mind. Don't forget to include all those rock sim component weights. And then assembly testing should continue here. So you should still be doing testing in your critical design. Next. So we see the comparison in your reports. So the CDR is basically just the same as the PDR, just a more refined version. So you'll start with your PDR report and you'll just kind of mature the design a little more and copy those elements into the CDR. Next. Flight readiness. So flight readiness is kind of like the critical design where, okay, now everything's designed, we've procured everything, flight readiness should be built. This is the phase where everything should be flight ready. Your rocket should be built, your payload should be built. And then design, build, and fabrication should be complete of both the rocket vehicle and the challenge. There's also a safety section in your report, and then your project management as well should be wrapping up. All of your tests should be complete by flight readiness. All of your requirements should be met. And then your budgets and schedules should be finalized. I mean, beyond flight readiness, you shouldn't really be spending any other money other than traveling to launch weekend. Which you'll put in your flight readiness report, right? All the details of launch weekend funding and costs. And then scheduling as well. Much of your scheduling, 90% of your scheduling will be done by flight readiness. The only thing left really is that launch weekend, logistics, and then scheduling that final post-launch assessment. Next. So like we said, in a high level, flight readiness should show the vehicle and payload are ready for flight. So also note that the as-built vehicle and payload should match the latest design. So sometimes at critical design or what you presented at critical design doesn't match what you built. Things change or something changed where maybe something didn't come in that you procured and you had to make a modification, or there were some struggles during the assembly and fabrication and you made some design changes. So make sure to kind of relay those changes to us in your flight readiness report. And also make sure to update your simulations now. So now that you have a built rocket and you kind of know the weight of things and you know the weight of your payload, update your simulation to match the as-built rocket. And like we said, any discrepancies should be accounted for in your report. So just explain to us and make sure you understand why those changes happened and how it's going to affect the rocket performance. Like we said, all procurement should be complete at this phase and all testing should be complete as well by flight readiness. Next. So again, just a comparison of reports. Your FR is the same basically as your CDR, just making those final changes from the design side to the build side. So it's like, this is what we're going to design at CDR, or this is what we want to build. And FR is, this is what we did build. Next. And then your post-launch assessment. So as far as reports go, that'll be your final report. This is after launch weekend. You'll do a vehicle performance analysis. Prior to launch weekend, you're going to make some predictions on the altitude and the velocity and the acceleration of your vehicle. You're going to make predictions of your challenge performance as well, like what altitude your payload is deployed at, and what is the descent rate of the payload, what is the descent rate of the rocket prior to launch. And then your post-launch, you're going to kind of perform, well, what did you predict or expect to happen with what actually happened? So you're going to do a comparison with your altimeter data, your GPS data, any other data that you pulled during flight on launch weekend, and doing those comparisons. And then just being ready to explain any anomalies. So something went, completely unpredicted, something you didn't expect to happen. please try and just explain that to us in your post-launch assessment. Try and understand why something happened or didn't happen in your flight on launch weekend. And then for project review, you just provide a project review in your post-launch assessment. So you're not really focusing on budget schedule anymore. It's more like maybe a high-level lessons learned. Next. So we can see the post-launch assessment is kind of the shortest report. It's the easiest report, just the team summary, and then just discussing your vehicle and your challenge performance and analyzing those discrepancies, if there are any. Next. So please use the report and virtual templates. So on the website, if Rob or Connie again could put the scoring rubric link in the chat. There's a screenshot of it there. So it's the scoring rubrics. So you can see the competition proposal, the PDR, the CDR. So you see the Word documents. Those are your templates for your written reports. And then you see the PowerPoint links or documents. Those are for your virtual reports. So you see there's only 2 of those. So then please review the template at the start. So like I said, proposals are due almost a month from now, December 11th. You should be reviewing, like downloading and reviewing that proposal template now. The template kind of guides you. It's kind of this is what you need to know, or this is what you need to present by December 11th. So you're not, no surprises. You'll get there and you'll kind of meet those expectations by December 11th. Next. So the written report templates, so they're basically just a plug and chug. You're going to address each bullet point. Like I said, if you review the templates ahead of time, you can kind of see, in the screenshot example there, just providing an overview of the key components. So it's like, okay, well, I'm going to include some pictures. I'm going to discuss, hey, this is the nose cone we selected. These are the fins we selected or we're proposing. And then you can reformat accordingly. So also remove the bullet points that don't keep the bullet points in. It's not like a Q&A where you leave the Q and then put in the answer. You're going to want to delete that all out and just kind of have sections, right? So you could create a subheader there on that example. It says 4.1. You could 4.1.1, and then you could title it Overview of Key Components. And then you can have a 4.1.2. You half a page on alternatives. So please feel free to use the formatting. It kind of helps us when we're reviewing as well, kind of helps us mentally break down the sections. Nothing really hurts. And I'm sure you've all been there where you're reading a document and it's all just text. It's pages and pages of text or paragraphs, right? And it's like, well, I don't know what's where, and I got to go through and kind of, it's an eyesore. So having those subheaders in there helps to break down and quickly sort out, as I'm scanning your document, it's like, oh, alternatives, there's a header right there. I know this is the alternative section. Proposal is probably the most work. It kind of seems counterintuitive. You think the one towards the end is the most work. Proposal is when you're actually building everything from scratch. Veteran teams are lucky because they have a proposal from a previous year, usually to build off of. But everything builds off the proposal. So make sure to put some time and effort into that proposal. The PDR, CDR, everything else gets easier if you have a good proposal. You have the documents created in that proposal. And then use the MS Word functionality, right? We mentioned headers, subheaders, even captions and references. So I remember, when I was a student having to put in the captions, figure 1, figure 1.2, and then you'd add another figure in between and it would move, and then you'd have to go renumber everything. Microsoft Word has functionality now where you just give it a function, and as you move the letter or you move the image, it renumbers everything for you. And then even creating those references, right? If you're referencing an appendix H, you type in appendix H and it'll automatically renumber. So make sure to look into and understand the MS Word functionality. It'll save you a ton of work. Next. Virtual report templates. So you do 2 of these virtual presentations, well, actually 3, because you do one on site. It's not virtual. Same thing, plug and chug. There's going to be 10 slides or so. And each slide kind of, just like the image shows, kind of has a few bullet points that you're going to want to discuss in that slide. So you'll pull your data from your written report. So the virtuals aren't really anything new. It's kind of just, it's a summary of your written report. So after you hand in your written report, whether, you hand in your PDR, a week later, you kind of just pull out the relevant information, you pop it into your virtual presentation. And then practice your presentation. So some tips, we don't give much time. There's 30 teams, so we have to go through a lot of presentations in that week. So please practice your presentations for timing, just to make sure that, you're not saying too much or you're transitioning properly. And then use images over text. So, if you got a table or you got something like a paragraph written talking about the weight of your rocket or talking about the size, it's much easier to just put a picture with the images labeled on the picture, right? And you don't need to read the image. The readers and reviewers, such as myself, can just instantly look at the image and obtain all that information quicker than reading through a paragraph. Next. And we'll get to questions. We'll definitely have time for questions here at the end, so we can come back and cover these slides if you guys have any questions. So fly sheets is the third component you submit with each milestone. And again, it's just a plug and chug. We provide you a spreadsheet just as the screenshot shows, and then you just fill in the data as it shows. So ensure your data aligns between your written report and your fly sheet. So again, you fill out your written report first, and then you put those values into the fly sheet. And we do review both. So sometimes, and it's very frustrating for me when I see discrepant values. If I see a descent rate of 20 feet per second on your fly sheet, but I see in your report it says 16 feet per second, then how do I know, which one is right? Are there two people filling out the sheets? Is one later than the other? Did it change, between the time you wrote the report and the time you filled out the fly sheet? Please be consistent in your documents at each milestone when you're submitting information to us. And then also to ensure you're filling out the correct tab for your fly sheets. There's an image there towards the bottom. It says proposal, PDR, CDR, FR. So the fly sheets come in one spreadsheet as an attachment, and then you can toggle through the tabs. So at proposal, make sure you're on the proposal tab, and that'll highlight the information that we need at proposal. So not the entire fly sheet doesn't need to be filled out at proposal, just a few of the sections. And then you can see there as well, I also put notes kind of at each section. So if you hover over the red, and unfortunately Rob can't do it because we don't have a real sheet, but you'll see the little brown box will pop up. And it kind of tells you, some guidance where that information comes from, whether it's a team choice or comes from simulations or comes from manufacturing data. Next. So this is, again, some of the information I talked about in the previous slide. So the fly sheet's transmitting the rocketry or the simulation performance data to us. And just by me inspecting your fly sheet, I can tell if your simulations are accurate. I can tell if your component selections are accurate. So me and Frank will review your fly sheets. And then also keep in mind that some of the fly sheet rocketry data have required values, such as the descent rate. It's one of the requirements. So don't put a descent rate in there that's some arbitrary number. You're going to get a response that says this needs to be this specific number. So you need to change whatever it is in your design so that you meet that requirement. And then fly sheets again are required each milestone. So proposal is a couple of things. It's progressive, it builds, right? And then PDR, your few more fields are filled by FR. The entire fly sheet is filled. Next. Budgets. Oh, there's a great little budget there. Budget requirements that help you manage your budget. So one of the things we see too is teams kind of mismanage, or especially earlier on, you're not paying attention to your budget. You just assume that the money's there and all the bills are going to be paid, right? And then everybody kind of wants the best of functions. So the avionics guys are buying the top of the line GPS, and the rocket guys are buying the top of the line carbon fiber, and the parachute guys buying the gold foil plated parachute. And next thing you know, you guys are over budget and it's only PDR. So that's why we require you guys to do budgets and submit them at each milestone. So just some tips. Your team lead should create and maintain a spreadsheet for your budget, and you just include a snapshot of that spreadsheet in each report at each milestone. And then at proposal, right, you're just going to split it into sections. So you're not going to really have too much detail. You could just say, well, at proposal, we're going to allocate 1,500 for the challenge. We're going to allocate 1,500 for vehicle. and we're going to allocate 2,000 for travel. And then each milestone, when you go into PDR, you're going to further refine that. So maybe now a vehicle has nose cone, $50, rocketry standard tube, $20, avionics, $100 for an altimeter. And then, we expect to see that progression. Veteran teams, you may kind of know this ahead of time, but don't throw too much. Don't throw all the detail into the challenge and into your budgets, right? We know that you know how to make a budget, and we know you're going to drill down. So kind of just start, as shown on the screen. So a proposal, just submit as a high level and start to drill that down. And then remember to include headers in your budget, such as, which subsection is this component's item for. Components, include vendors as well. So we've had times where teams have purchased a component from a substandard vendor or or not the correct manufacturer. So we kind of want to know, when we're reviewing your reports, where are you buying your rocketry components from? So please include the manufacturer and the vendor in your budgets that you are submitting to us. And then, of course, the cost. And for some teams, shipping is a big factor, especially if you're a team that's far away, such as Hawaii or Alaska. These shipping costs may come in and affect your budget. So make sure to keep those in mind as you're tracking your budget. The budget here is for your reports. There's also another budget that we submit into the portal, I believe. That's Rob and Connie's department. So the budgets I'm talking about here are the report budgets, which is my department to review. There's some budget guidance in Appendix C of the competition handbook as well. Next. Similarly with schedules, schedule requirements are to help you manage your schedule. I'll say right now, that's one of the big things. Teams struggle with schedule. We find every year that teams always have to accelerate their schedule at the end, into February, March, and April timeframe. They're putting a lot more work in than they did earlier in the program. So if you develop a good schedule up front, you're going to save yourself from that crunch time on the back end. And then that crunch time also kind of leads to mistakes, leads to stress, leads to pressure, leads to failures. So schedules are big. Don't underestimate the importance of a good schedule. So again, your team lead should create and maintain a Gantt chart, and then you'll include a snapshot of that Gantt chart at each milestone in each of your reports. So there's a picture there of a Gantt chart style schedule with interconnecting, kind of each, certain items may depend on the completion of other items. So, a procurement, for example, may depend on, a test or design choice or a milestone or a gated. And that's how a Gantt chart works. It kind of adds those interdependencies between the schedule items. So make sure to use Gantt chart. I think Excel has a Gantt chart option. If you go into Excel, you can open a spreadsheet as a Gantt chart. There's other apps and programs that are specific Gantt chart styles you can use as well. Don't forget to include in your Gantt chart, you're going to want to look at the report deadlines. You may want to include some, simulation windows or trade study windows early in the design phase. Maybe testing as well. You're going to say, hey, testing, we want to start testing maybe January 1, and we want to finish testing, February 28 or something. And then Rob mentioned, we'll get a little bit more into project management on another webinar. So this is just kind of high level for your reports. And then your procurement window, right? You could say, hey, maybe we want to start procurements in, January 1st, and we want to be done by, March 1st to be able to be complete in time. So have those little windows baked in, and again, you'll refine this Gantt chart every milestone. You'll see that, you get a lot more detail and you got a lot more accomplished. So don't forget anything in your schedule. Again, there's schedule guidance in Appendix C of the competition handbook. Next. Yeah, we'll try and save some time for questions. I think there's only a couple more slides left here. So test plans are to ensure your components function individually. So team lead should create a test plan spreadsheet. And then you just like the other two documents, you include a snapshot of the test plan at each milestone. Test plans should be created for all components and assemblies. And it's left to the team to determine which components you want to test during design, when to test. That's your schedule we just talked about. What constitutes a successful test? So maybe you're testing an altimeter, or maybe you're testing a parachute, or maybe you're testing a GPS device, or you're testing a mechanical device that allows a parachute release or something. So you got to plan those, schedule them, and then what constitutes a successful test. So hopefully you're thinking about testing each one of these components and assemblies individually, such that when they're all brought together, there's a lot more confidence that the entire rocket and payload will function as planned. Tests may culminate in a full-scale flight test. So I know some of the teams, especially the veteran teams, work very well with their mentors, and they always aim to have a full-scale test flight done prior to coming to launch weekend. So that's not required, but something to look forward to, especially for the veteran teams as you start to design and build. If you can get in a full-scale flight, please do so. And then again, there's more test guidance provided in Appendix C. Next. And then finally, requirements verification. So this is a big part of project management, and it just ensures you're designing properly. You're designing what is asked for, what the organizer, such as us, FNL, is asking you to design. So again, team lead should create a requirements verification spreadsheet, and then you'll include a snapshot of that spreadsheet every milestone. So of course, requirements are provided in the competition handbook. If you go to the handbook, there's a challenge requirements, there's a general requirements, there's vehicle or recovery. There's pages and pages of requirements. So you want to ensure that you're addressing and satisfying all those requirements. So you're going to create a list of requirements in a spreadsheet. And then what you're going to do on top of that is determine how you will satisfy that requirement. For example, it might say descent rate is 20 feet per second. How do you satisfy that requirement? You choose a parachute and run a simulation, or you do a hand calculation that determines that your rocket's going to descend at that rate. So you'll have a column beside the list of requirements. For every requirement, you're going to list how you're going to satisfy each one of those requirements. And then also, too, it's good to list the person responsible for satisfying those requirements. So you're going to kind of split up. Maybe the avionics team is responsible for these ones, and the team lead's responsible for the business management side of it, and the structures guys are responsible for the structure side of it. And then also to list the status of the requirement verification. So sometimes it's like it's verified ahead of time, it's verified in the design cycle, and sometimes it's not verified until there's a full-scale flight. So we just want to know the status of each one of your requirements. And then if you miss a requirement, that will lead to large design changes and schedule issues. We've had teams before who've missed requirements such as motor ejection, which is a requirement for your rocket. And they've managed to design something in that actually sealed the motor requirement and prevented it from happening. So there's safety issues too from missing requirements. So we try and catch those during each one of your design reviews. And again, more support in Appendix C. Next. And then finally, some just report tips and tricks. So veteran teams, I think I mentioned this in an earlier or another webinar, do not simply reuse your old reports because the templates will change every year. So we tend to maybe sometimes change the order of what's required in the bullet points. Maybe we increase the amount of detail that's required in the bullet points, or maybe we eliminate a bullet point altogether. So the veteran teams, please don't just copy, or don't just start with the 2023 version and then just change the date, because we'll see those in our scoring rubrics. We'll see that you're missing something or you've added something that doesn't really belong anymore. So make sure you're downloading the new templates. Ensure your units are consistent in your reports and simulations. So every team should be deciding like the next meeting within the next week, what units you're going to be using, whether it's, feet per second, miles per hour, meters per second, and be consistent with those units on everything, on your simulations, on your reports, on your virtual presentations, on your fly sheet, So agree on those units and be consistent on each report as well. Don't put feet per second on the proposal and then meters per second in the PDR. So stick with one set of units. And then a picture is worth 1,000 words, right? Use pictures more than text. So in your reports, in your virtual presentations, please include pictures, especially of your component selections. So preliminary design, critical design, you're going to select a switch, you're going to select an altimeter, you're going to select a GPS. Include a picture of those components, not just a description or not just a table. Include pictures. Much appreciated. Next. And then finally, learn and acquire RockSim as soon as possible. And especially for the new teams, I'm sure the veteran teams are aware of this. But for the new teams, you need RockSim like now. And there'll be a RockSim webinar coming up here in a couple weeks to help the new guys learn that RockSim. And then include RockSim data and images in your reports and fly sheets, especially the fly sheet. A lot of that information in the fly sheet comes directly from your RockSim data. So make sure you understand what we're asking for in the fly sheet and how to get it out of the RockSim tool. Like I mentioned, use MS Word. There's a lot of functionality in there to help you make things easier. And then use appendices for large tables or data. So as you're reading through a text document, right, if there's a table that goes maybe over a page, if it extends onto 2 pages, that's probably best to put that table in an appendix. And then in line, just say, see Appendix H or Appendix J for the complete table. Next. That should be all we got. That's time for questions. Yeah, Nicole, you can come off mute.
Okay. Yes. Much appreciated. Thanks for the meeting, everybody. I guess I was hoping to have a little bit of clarification. You mentioned the kind of the procurement, or like the procurement along the different milestones, but I was just hoping I could hear it a bit more consistently one more time. What I heard and absorbed was like getting avionics components after we get feedback from the PDR would probably be a good call, but getting like rocket components and payload components should happen after we get feedback from the CDR. I definitely know for the team last year, we really struggled doing procurement really late, but not feeling like we could procure until something like CDR, and not really having much time for much testing last year. And so again, I was just kind of hoping to hear your thoughts on like when we should start procuring what things across those deadlines, knowing that there's only 5 weeks between, I'm looking at our calendar right now, 5 weeks between CDR and FRR, and we need to build and test during that period as well.
So last year was actually an anomaly. Last year, we kind of went counter to what we've always been kind of preaching to teams about procurement. Last year, we wanted teams to procure as early as possible, but because the challenge was a fabrication challenge, so we needed you guys to have that raw material and be building those test samples and components and things like that early on in the design phase. So almost at proposal, we wanted you guys to procure as much as possible. Usually, though, in all the years before that and going back this year, we kind of want you to wait a little bit before you start procurement. You can start procuring smaller things, such as, especially for a veteran team such as yourself, right? You guys know what altimeters there are out there. So if you want to go and buy some new altimeters at proposal, we're totally fine with that. It's more for the new teams. We don't want the new teams to kind of jump the gun, especially if they don't really understand altimeters or GPS, right? We want them to wait a little bit into the design phase to kind of get a thumbs up, or even during that first virtual review, for example, right? Myself and Frank will kind of say, hey, that's a good altimeter you selected there. You can go ahead and purchase that. Or, hey, we're not too sure about this GPS. It looks a little, for some other application, we prefer you kind of look at this list instead. And then especially with the rocket itself, in previous years, not last year, but the years before that, one of the things that we found is that teams will show up with a rocket, and there's always a rocket and a challenge, like a payload. There's 2 kind of components. They would show up with the rocket, but the payload would never really match the rocket. It was like the payload was too big to fit in the rocket, or the payload was too small. And to me, from an engineering design perspective, that just means that they made the rocket selection prior to the maturity of the payload. And then after they made the rocket procurement, the payload changed and it iterated again, and it either changed in size or weight or something, and now it doesn't properly integrate. Right. And so you see that too, not just with rocketry, but in, all kinds of products, whether they're airplanes or rockets. There's also kind of a mismatch between the design cycle and the procurement. So does that answer your question? Does that help clarify a little bit?
Yeah, that definitely makes sense. I think since our first experience was with last year, we were much, yeah, you're right. It won't be as much of a manufacturing challenge besides the drone.
Mhm. So definitely wait until at least after proposal to start procurements. And then what we find too is a lot of teams have procurement trouble because of just grant trouble with their school, or and we'll have another webinar, we'll have an office hours that kind of helps advisors deal with that and making sure that teams can start their procurements early on in the year, as early as possible.
Okay, cool.
And I'm
Thank
just
you.
going to add on to that with the procurement is teams, advisors, if the reimbursement is going to be going through the university, those conversations and setting up your budgets should be happening right now so that you guys will have the ability to start using the funds. If you're not working with your grants office now, then you need to be doing that. That needs to become part of your project management and your project schedule, is to sit down with the grants office and make sure you're going to be good to go to start procuring when it's time. Don't wait until you need the product. Have that all in place beforehand.
Awesome.
And
Thanks. Good question.
Ann Lee, looks like.
Yeah, I was going to mention that about getting your administrative or your advisor, up on it on the budget that you need for your design, and prove that you need that design to make it critical for your competition, and make sure it's reliable and it's a good design and it's going to work. Also, getting back to the fly sheet Mark mentioned, it should be like 30 teams now. I believe probably maybe 4 or 5 or 6 people that are going to have wrong calculations. Get together with your team, agree on your fly sheet before you send it in. Just get a meeting together, not just one person that's going to shoot some numbers on, but get a couple of your team members together to agree on the fly sheet you're going to send.
And I'm going to come off of that is making sure that you guys, Mark took you through proposal, each one of the design reports. There is so much importance that you submit your paperwork on time. We cannot express that enough. Your papers, your reports are going out to judges, they're going out to our team, and for everybody to be able to review your papers and be able to give you the feedback so that you can make the changes and make the adjustments and make the purchases that you want. You need to have your paperwork in on time, and that would be helpful to Connie, correct, Connie? And it would be helpful to Rob, that you guys have it in on time. And if you aren't going to have it in on time, to make sure that you are in communication with Connie and letting her know that, hey, we're aware that we're late. We're going to have it in, this time, because you guys have Monday, 100%, Tuesday, 80%, Wednesday, 60%, Thursday, 40%, I think it is, and Friday, 20%. If I did that all right, 80, 60. Well, anyway, so on Friday afternoon, all of the reports go out to the judges, so they start judging it that evening. Thank you, Rob. So just a reminder, not to be, but really trying to encourage you to not procrastinate, but to plan ahead. And I'm sorry, Anne, you have your hand raised.
Yes, sorry, I was wondering, I don't know, I came into this meeting late, so if you had said something about this already, apologies for that. I have a question about the COTS chassis. On the handbook, it says that we can't use a COTS chassis, but then later on it says that we can reverse engineer and modify one. So does that mean we can use a COTS, but we have to reverse engineer it and modify it?
Yeah. So we'll have a challenge webinar, I believe, next week. So we'll talk all about the details of the challenges next week. But yeah, since you asked now, yeah, you can use we don't want to see a COTS chassis like just as is, but if you want to buy one and then reverse engineer it and kind of build it to the same spec as the COTS one, that's fine.
Okay, thank you so much.
Cool.
Nicole.
Okay, sorry, I have another question. I know you guys went over testing, and I guess I was wondering, maybe you did went through this and I kind of looked away for a second, but when it comes to like the kinds of testing expected, I was wondering if you'll have like a webinar about like ways you can test and kind of like tests that you should do on each component, or any advice on that in general.
We should have a webinar on testing. That's a very good
Right?
idea, Nicole.
Right. Yeah,
So
what's a right way to do
But I
it?
think
Yeah.
that can go in with the challenge, Mark.
What we can do is we could we could add it where we'll add a slide where appropriate. So challenge, I'll talk about challenge testing. The structures webinar, we could talk about structures testing. There's an avionics webinar, we'll talk about avionics testing. But it's kind of left to you, really. It's kind of like, well, what do you know works, and what are you confident with that's off the shelf, and what are you uncertain that may not work, right? Especially with the challenge, right? The challenge will be a lot of testing. The rocketry stuff is all kind of COTS. So it's up to
Yeah, I
your
think
team.
each webinar kind of says that in a way to test whatever webinar is being broadcasted that night. We always try to encourage testing.
I have one more if no one else has one. This might be cheeky though. I was wondering if you guys had a rough idea of how many requirements we should be digging out of the handbook, because I know sometimes it's a must statement or a will statement or a shall statement, but maybe that's for us to find out.
All of them.
Okay, all of them, got it.
I'm gonna be hard on you, Nicole.
And if you have any questions
Well,
or
I'm
doubts
laughing
on,
because
on
I'm
testing,
thinking, Nicole, you think we actually counted those? How many musts there are? I was just like,
if you have any questions on testing, you can look at me and Mark or your mentor.
Yeah, we'll review your test plans as well. So if you have too much testing going on or you don't have enough testing going on, we'll give you that feedback after we review your reports, each report.
Mhm.
it is 6 o'clock or 5 o'clock. Sorry, I haven't turned my clocks back yet. My apologies.
It's 6 o'clock somewhere.
So I think at this time, Rob, you can go ahead and stop the recording, and